Good afternoon. This is another session. In this session, we want to play with this particular question under radioactive decay. This is nuclear chemistry. Now the question goes thus. The nuclide X of atomic mass 210, atomic number 81, decays to the nuclide atomic mass A, atomic number 82, nuclide Y, in 4 successive radioactive decays. Each decay involves the emission of either an alpha particle or a beta particle. What is the value of A? We should first note that all alpha particles are helium nuclide. So what does that imply? Now, it implies that when you have helium, atomic mass 4, atomic number 2, so this is also called alpha particle. So that is why we call it helium nuclide. Then when we say beta particle, this is the representation of beta particle, -1, then 0. So this is beta particle. So what does this mean? Now the next line of action from the context is that we were told that the emission of these particular elements occur in 4 successive radioactive decays. Now when there is radioactive decay, it either emits an alpha particle, a beta particle, or a gamma particle. But in this context, we were told that the emission is just alpha and beta in 4 successive decays. But we don't know the number of alpha particles emitted. We don't know the number of beta particles emitted. We now say let the number of alpha particles emitted be n. That is the first thing. Because we are told that there are 4 successive radioactive decays. Now, if we are having n alpha particles, and we know that the number of beta particles is unknown, then the number of beta particles emitted is equal to 4 minus n, because the total number of particles emitted is 4. So since alpha, the number of alpha is represented as n, then the number of beta will now be 4 minus n. So now let's try the chemistry of reaction. Chemistry of reaction. That is the next line of action. Let's try the chemistry of reaction for this radioactive decay. Now atom X of atomic number 210, then 81, then decompose or decays to element Y of atomic mass A, atomic number 82. Then we are told that we have alpha and beta decay. So what does that mean? That means we are going to add n number of alpha particles. That is n, He, 2, 4. Then since the number of beta decay is 4 minus n, so we have 4 minus n. Then our beta particle is E, -1, 0. So here, let's check what will happen here. So here, it decays to 82, atomic number 82, the atomic mass A. So the context now says what is the value of A. So we need to expand this. So the chemistry of reaction for this decay is that element X decomposed to element Y produces n alpha particles and 4 minus n beta particles. So we need to equate the atomic number on the reactant part to the atomic numbers on the product part. So what does that imply? 81, which is on the reactant part, is equal to, that means 82 plus, now we are going to multiply this n by this atomic number of this helium. So n times 2, that gives 2n. Then plus, then this as well, we are going to expand this by multiplying -1 with 4 minus n. So that means 4 minus n multiplied by what? minus 1. So what does that imply? We can now say that 81 is equal to 82 plus 2n plus, then minus 1 times 4, that is minus 4. Minus 1 times n, that is what? Plus n. So this is the reactant, this is the product. So what does that imply? 81 is equal to, now let's collect the like terms. This and this put together is 2 minus 4 is equal to, that is 78 plus 3, 2n plus n is what? 3n. So let's make n the subject of the situation. If n is made the subject of the situation, that means we have 81 minus 78 is equal to 3n, which implies that 3n is equal to 3, which also implies that n is equal to 1. So now, since our n is 1, that means we have just 1 alpha decay and we are having 3 beta decay. So what does that imply? So we can now substitute our n to be 1 and rewrite the equation so that we can get our a. So since our n is known now, we can get our a. Now the mass number of the reactant, which is 210, is equal to the mass number of the product. So addition of this a plus this factor here plus this factor here will make us to find the value of a. So since n is known, let's plug in 1 for n in that equation. So the mass number of the original element, which is 210, the reactive element, then is equal to the mass number of element y, which is the new element, plus then 4n, 4 times n is 4n, then plus, then multiply this by 0. Anything multiplied by 0 gives what? 0. So 210 is equal to a plus 4. Then our n is already 1. We substitute 1 for n plus 0. So numerically, we have 210 is equal to a plus 4 times 1, 4. 4 plus 0 is 4. So if n is made the subject of the situation, if a is made the subject of the situation, a is equal to 210 minus 4. So a is equal to 206. So hence, what is the value of a? Hence, a is equal to 206. So that implies that the mass number or the atomic mass of the new element formed after the composition is 206. So that is the end of the class. So have a wonderful day. Thank you.